All right, we are starting in on chapter 9, which is all about simplifying square roots. So, the first thing we're going to take a look at here is we would like to look at a list of the perfect squares. So, when we say a perfect square is a number that you get when you multiply a number times itself or that you square a number. So, for example, 225 is a perfect square because 15 times 15 equals 225. So the list that we're really going to focus in on is we have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. This is a good list to start with. Remember that you could keep finding more by just simply going 16 squared, 17 squared, and so on. You could keep finding more perfect squares. But this list will give us a good list that we're going to use as we simplify square roots. Now, I think it's important to know the vocabulary. So when we look at a square root, let's talk about the parts. So the first part that I'm going to focus in on is the symbol itself. The symbol is what we call the radical. The radical is the symbol of the square root. A number inside the radical is called the radicand, and that is the number inside the radical. The number in the front that is multiplied to the radical is the coefficient, just like when we would write 3x, the 3 is the coefficient to x. Here, that number is a coefficient to the radical, and it means that we're multiplying the radical by that number, just like 3x means 3 times x. Okay, so that is the parts of the radical. Now, what we're going to do to simplify square roots, we're first going to check if the radicand is a perfect square. The way you do that is you simply, on a calculator, press the second button, the x squared button, which is going to give you a radical, and then you simply type in the radicand. If it comes out as a whole number, then it is a perfect square and you're done with it. If it's not, then what we're going to do is we're going to start dividing the radicand by perfect squares that are on the list. We're going to start at the biggest one possible. So we look at what numbers could go into that, and then we start dividing from there, working down, because we want to try and take out the largest number, largest factor that goes into that radicand. Once we do that, we're going to then write down our two numbers. Remember, as we do the division, we're looking for that number to go evenly into it. So it should go in as a perfect whole number. Okay? And then what you're simply going to do is you're going to take the square root of that number, and that comes outside. And then the part that is not the perfect square stays inside. If there is a coefficient, what you're going to do is when you bring that number outside, it's just going to simply multiply to that coefficient. All right, so let's give it a shot. So the first one here, we have square root of 441. So notice 441 is above our list. So what we're simply going to do is we're going to take second x squared, that gives us our radical, type in 441, press enter, and this one comes out to be a whole number answer. So that tells me that the square root of 41 is actually 21. That's all we would do there. Okay, so let's try the next one. So I come in here, 72. 72 is not on that list. So if we scroll back, remember, here's our list. Notice there is no 72 on there. So it is not a perfect square. So what we're going to do is we're going to start in then, and I'm just going to copy those numbers back down here. So 1 second here. So these are the numbers that I'm looking to try. Okay, so these are the numbers that I'm looking for. So I start at 72. Well, the highest possible number that goes into 72, the biggest one here, the next closest to 72 is 64. So I go 72 divide 64. So if I go 72 divide 64, you end up with 1.125. Well, that doesn't go into it evenly. So now we're going to go 72 divided by 49. Doesn't go into it evenly. 72 divided by 36. That one comes back as 2. So what I'm going to do is I'm going to write this as 36 times 2. Well, now we take what is the square root of 36. In other words, what number times itself equals 36? And that would be a 6. So that comes out of the radical, and the square root of 2 would stay inside. Okay, let's try number 3 here. So on number 3, we start with 75. And if you notice at the list I wrote up above, 75 is not on that list. So 75 is not a perfect square. So now what we're going to do is we're going to look for a perfect square that goes into it. So if I start at 75, I have 64. 75 divided by 64, nope, not a whole number. 75 divided by 49, not a whole number. 75 divided by 36, not a whole number. 75 divided by 25 is. So 25 times 3 equals 75. So now we're going to take the square root. Well, 25 is a perfect square. So the square root of 25, what number times itself equals 25? And that would be 5. And the square root of 3 would stay inside. Okay, let's try 245. So we start off and we say, okay, is 245 a perfect square? Well, that's bigger than our list, so let's try it. 245, nope, comes out to be 15.65, so not quite. So now I start in and I try to find something that goes into 245. Well, if we start in and we just start dividing. So 245 divided by 169, 245 divided by 144, 245 divide 121, 245 divide 100, 245 divide 81, 245 divide 64, 245 divide 49, and it goes in 5 times. So what we would do is we'd rewrite this to say 49 times 5. Well, now we look, what is the square root of 49? The square root of 49 is 7, because 7 times 7 equals 49. And then we have the square root of 5. So 7 square root of 5. Okay, so now let's go down. What do we do when we have a coefficient in the front? So first off, I'm going to copy down my numbers again so I know what I'm using. The perfect squares. I would strongly recommend memorizing these because that will help you. That just makes it easier on you to be able to find these really quick and much more efficiently. Okay, so when we look at this problem, this first one here, number 5, it says 5 times the square root of 45. So what we do is we start off and we say, okay, I've got 5. Now I look at my list, 45 is not on there, so I start dividing and I say, okay, does 45 divide 36? No. 45 divide 25? No. 45 divide 16? No. 45 divided by 9, and that is a yes. So now what I do is I take this and I say, okay, what is 5, that's on the outside, times the square root of 9 is 3, times the square root of 5. 5 times 3 is 15, square root of 5. And there is our final simplified answer. Okay, this time they have a -1 in front. So if you want, you could even write it this way. -1 times the square root of 128. So we start in, we look at what goes into 128, and that would be 64. And 64 goes in 2 times. So now what is the square root of 64? And that would be an 8 times the square root of 2. So now negative 1 times 8 gives me negative 8 square root of 2. Okay, let's try number 7 here. So on this one, we have negative 6 times the square root, and we're looking for 63. What perfect square goes into 63? So you can start dividing them out, and you would find that it was 9 and 7. So now we take that and we say, okay, that's a negative 6 times, what's the square root of 9? And that's 3 times the square root of 7. Well, negative 6 times 3 is negative 18. The square root of 7 stays inside because it is not a perfect square. And that's how we would simplify that. And then on number 4, we start off and we have 9 times the square root of 36. Well, if we look, the 36 is up here. It's a perfect square. So what that means is the square root of 36 is just 6. 9 times 6 is 54. So this one, everything came out of the radical. I simplified the square root of 36 to be just a 6, so there is no radical left. And that is how we basically simplify square roots. We don't want to get decimal answers. We're going to leave them like that. We're just looking for those perfect square factors that go into the radicand. All right, have a good day.